Hello students, how are you? I think you are very much fine and staying safe at home. Students, today we are going to learn or discuss about Ncert Class 9 Mathematics Chapter 1 Number System. So before going to start our chapters, first of all we have to recall some terms or definitions so that the chapters become very much easy to us. So let's start. First of all, the name of this chapter is number systems. Students, we know that without number we can't imagine anything in this world. At the nature, when we see there are numbers and numbers, because without numbers we can't imagine. If you see, the numbers of trees are there. If you see on the road, numbers of cars are there. And there are so many games of numbers there. The nature is full of numbers. So let's start our chapters. First of all, we have learned how the natural numbers and whole numbers, integers, how we have to represent on the number line. First of all, if there be a number line, and if you start your journey along this line, and there are so many numbers you can see, such as 1, 2, 3, 4, 5, 6 and so on. Similarly, if you go to the back side of 0, left side, you will follow that -1, -2, -3, -4, -5 and so on to the back side. If you go towards this point, this direction, then if you collect some digits or numbers, then suppose 1, 2, 3, 4 such like numbers you are collecting, that means you are collecting the natural numbers. That means you are collecting the natural numbers. Basically, we denote this natural number as capital N. Similarly, if you back and take 0 in your bag, then the collection become natural number including 0, it will become whole number, and we write whole number as W. The set of whole number is denoted by W, capital N for natural numbers, capital W for whole numbers. If you go back to the backward direction to the left side of 0, then you collect all the negative numbers. If you collect them, they are nothing but the negative integers, and all of them you see all the whole numbers, the negative numbers become the integers. Integers are denoted by capital Z. There are positive integers, that means natural numbers 1, 2, 3, 4, 5, 6 and so on to the infinity. At the same time, 0, if you include in natural numbers with 0, then it will become the whole number. Apart from the negative numbers, if you collect, then total collection will be the Z as the integers. So these are the basic or previous idea or primary idea which we have learned actually previous classes, and this is the whole numbers, and this is for natural numbers. Now, apart from these numbers, if we put here half, this type of, it may be 3 by 2, it may be 5 upon 2, such like numbers. If you want to come here also, minus 11 upon 2, so this type of numbers also be there, and we know that this type of numbers are including in the set of rational number. Rational number basically we denote as capital Q. The definition of rational numbers says that when a number is expressed as P by Q, suppose 5 by 7 is a number which is expressed as P by Q, where P adds 5, Q adds 7. Then 5 by 7 is called the rational number, which is denoted by Q. You see here, this Q, that means the rational numbers, are also including 1, 2, 3, 4, 5, 6, 0, and these all integers are also including in this rational number Q. That means if you take a bag and it is the bag of Q, here be natural number, here be whole number, and here also be the integers. At the same time, you see there some fractional numbers also. We include all of them to this number, rational number. The definition of rational numbers says that when a number is expressed as P by Q form, where P and Q are integers and Q not equals to 0, then we say that the number is the rational number. If we write this, so what type of definition we can write? Let's write the definition of a rational number. So rational numbers, the numbers which can be expressed as P by Q form, where P, Q are integers and Q not equals to 0. P and Q are integers. We know the integers which are positive integer, negative integer, and also 0. But here Q should not be 0. P may be 0, but Q should not be 0. Then the numbers are said to be a rational number. We denote rational numbers as capital Q. We denote rational numbers as capital Q. So students, we have to keep in mind the definition, because every time we have to recall this definition for the rational numbers. Let's claim it and give some examples for these definitions. So if 7 by 9 a fraction, we know that, but it is a rational number. It is a rational number because it is expressed as P by Q. If you want to consider the 6. Is it a rational number? Yes, of course, you are right. It can be expressed as 6 by 1, that is in the form of P by Q, where P and Q both are integers, 6 and 1 are integers. If you want to take any negative number, minus 7 by 9, is it a rational number? Yes, of course, because minus 7 by 9 is also in the form of P by Q, minus 7 upon 9, P upon Q, where both of them are integer. So it is satisfied the definition of a rational number. So there also belongs to Q as a rational number. So I think it is understandable. Now, if there be any number we consider such as in the form 6 upon 0, is it a rational number? Yes or no? No, because it is not in P by Q form. We know that Q not equals to 0. So this one is extremely wrong, because Q, according to the definition, Q must not be 0. So that's why you have to keep in mind. So here we should know that what is the rational numbers or what are not. So this is the basic of the previous lesson which you have already learned. One thing we should have to know that when we are writing P by Q as the rational number, or when we are representing on the number line the rational numbers, then you should know that when the P by Q forms some numbers, suppose 8 upon 6, a number has come. So will you write or represent this number as the rational number on the number line? No. See here, on the number line, you can't represent 8 by 6 in this form. We have to cancel out this, because here 8 will be cancelled out 2 4 and 6 will be cancelled out at 2 3s are. So 4 upon 3 will be the simplest form, the reduced form. We have to use this reduced form on the number line, because on the number line all the numbers are unique. We do not represent any equivalent fractional form of the rational number on the number line. It will be very much clear if we write on the number line. Suppose there be a number line and we want to represent some number. Suppose this is 1 and 2 and so on. So this is minus 1, minus 2. Let's clear about it. Suppose I am writing here, this is the midpoint of 1 and 2. So it will be nothing but 1.5, that is nothing but 3 upon 2. This point is as 3 upon 2. If you want to say, sir, I can represent this 6 upon 4. Can it be right? 9 upon 6. Is it be right? They are equal, it's right. But when you are going to represent here, it should be only 3 by 2. It is neither 6 by 4 nor 9 by 6. We have to represent the simplest form of the fractional form of the number. At the simplest form, such that there be no common factor except 1 between the numbers. That means it will be very much easily, we can say that where P and Q are co-prime. Co-prime number, that is the numbers having 1 as the common factor, having only 1 as the common factor. There is no common factor except 1. That is the HCF of them is 1. That means they are co-prime to each other. There may be 2 upon 3. There may be 10 upon 9. We can't cancel out between them. No cancel out fact terms will be there. So that means they will be in the simplest form. The denominator and numerator part must be the co-prime numbers. So I think it is clear to you very much, because it is the main the previous recapitulation. Just we have recapitulate now to clear the idea of this chapter.